In this video, we'll be looking at how to build an auto-scaling group using Vilatex Structura. For this example, we will integrate with an existing VPC and existing subnets within AWS. To start, we will define the variables needed for this project. We will need availability zones 1 and 2, a key name to access the EC2 instances, the VPC ID, and the 2 subnet IDs. Next, we will open up the toolkit on the right using Command / for Mac or Control / for Windows. We can search for resources using the filter at the top of the panel. We will search for AMI, and this can be found within the AWS data sources. Click and drag it into the workspace to add it to our project. The next resource we will be adding is the security group. We can find this under AWS Resources and then within the VPC category. Repeat this process for the auto-scaling group and launch configuration resources. Now that the resources have been added to the project, we can configure the AWS provider. For this example, we will set the region to deploy to as US West 1. The AWS CLI has already been configured and authenticated, allowing Structura to use the same credentials. We will go ahead and name our resources by clicking on each node and typing in the ID field at the top of the workspace. Open the security group's configuration by clicking on the node. For this example, we will open up the egress traffic to all using quad 0/0 for the CIDR block and setting the from and to ports to 0, the protocol to -1. For the ingress rules, we will open up port 22 and 80 for all incoming traffic, using quad 0/0 for the CIDR block, setting the protocol to TCP and using 22 for the from and to ports. The rule for port 80 will also have quad 0/0 for the CIDR block, TCP for the protocol, and 80 for the from and to ports. Lastly, we will set a name for the security group. This name will appear in AWS's console once we deploy. The Ubuntu AMI node is a data source. Data sources enable Structura to fetch data from a provider and return a value that can be used by other resources. In this case, we need the Ubuntu 16.04 AMI for US West 1, the region we specified earlier in the provider settings. For the ASG configuration, we will use the variables AZ1 and AZ2 for the availability zones, the desired capacity to 1, a maximum size of 2, and a minimum size of 1. We will also reference the launch configuration ID. This will get the ID of the deployed resource and will visually link the ASG resource to the launch configuration resource. For the launch configuration settings, we first reference the image ID from the Ubuntu data source. This will draw a pink dashed link between the 2 resources, indicating that this is a link to a data source. Set the instance type to t2.micro, select the key name variable, and set the name to demo_lc. We will also reference the security group ID. Open the project panel using / as a shortcut. Right-click and select New Module. This opens a dialog asking for a module name. Type ALB for Application Load Balancer. Clicking Add will create a new folder and a new file, both called ALB. Next, we will add the module resource from the toolkit. This can be found under Structura and then the node category. Select this resource and name it ALB. Also set the source to ./ALB. Click on the ALB.json file in the project panel to open up the module. We have already added the load balancer, listener, and target group. You can find the configuration for these resources in the description below. We are going to add the following variables to this module: security group, VPC underscore ID, subnet underscore AZ1 and subnet underscore AZ2. This time we will leave the values blank. Next we'll open up the Outputs tab and add ALB underscore ID. The value is referencing the AWS underscore LB ID, and we also add the target group ARN referencing the target group resource. The outputs of a module can be referenced by other resources in a parent module. Now we can go back to the root of our project. Select the ALB module resource. Now that we have added variables to this module, they will be listed here as fields. First we will reference the security group ID and set the VPC ID and the two subnets using the variables we defined at the beginning of this project. Next select the ASG resource and add module.alb.target_group_ARN to the target groups field. Now that we have completed all of the configuration for this project, we can run a plan. The plan reveals that 6 resources will be created. Next we can apply this project, which will deploy all of these resources to AWS. To validate that this project was successful, we can get the DNS name of the newly created load balancer and try to reach it via our browser.